All right. Now, this is lesson 5 of unit 8 for Algebra 1. If you're one of my students, you might notice that I titled this video differently than what is in the book because I think this is a better title and it makes more sense based on the content of the lesson. And we've already learned distributive property, so it makes their title confusing. So let's dive in and look at factoring by grouping. We're just could start it. We could also call this like intro to factoring, right? Because we haven't ever factored before. So factoring, what is factoring? I'll get to this in a second. What is factoring? Well, factoring is the opposite of the distributive property. So the distributive property, we multiply all the things together, and with factoring, we are unmultiplying. So for distributive property, we're turning multiplication into addition. In factoring, we're turning addition back into multiplication, right? So the first thing we're going to learn in this lesson is greatest common factor. Always, when you're doing a factoring problem, whether the instructions say factor or whether they say solve and you have something like a quadratic, we'll learn what that means a little bit in this lesson, and then even more in the future. But whatever the instructions are, if you're going to have to factor, you always want to start by looking to see if there is a GCF. Let's do a couple examples to show you what we're talking about. So we're factoring these using a GCF, a greatest common factor. Now, you may have seen greatest common factor before, but you were just talking about numbers at that time, right? And so for the number parts, those coefficients, the numbers in front, you're doing the same thing. So we want to know what is the biggest thing that goes into 18 and 27. Well, 3 goes into both. 6 goes into 18, but not 27. 9 goes into both. 9 times 2 is 18. 9 times 3 is 27. So 9 is in common. So when we are factoring using the GCF, the first thing we're writing is what the GCF is. So we're going to write 9. Now, are there any letters in common? Yeah, they both have a y. Now, this one has a y squared and this one just has a y, so we can't factor out a y squared. We can only factor out a y because it's a y squared isn't in common, just a y, right? After we do that, we open up parentheses and let's see, let me move this down a little. I need a little more space, I think. Kabloop, bloop, bloop, bloop. All right, there we go. All right, so because I want to show y'all what we're doing. After you write the GCF, you're going to open up a parentheses. And then what's going to go inside the parentheses is what's left, okay, when you factor this out. And what you're really doing to find what's left is you're dividing each term by that GCF. That's what you're really doing. We don't typically write this, but that is what you're doing, and if that helps you to write it every time, or at least at the beginning especially, then go ahead and do that. That's not a problem at all. So what is left when we factor out a 9y out of this first one? Well, it's a 3 because 27 divided by 9 is 3, and then there's just one y left. Y squared divided by y is just one y left, right? And then plus 2, because 18 divided by 9 is 2, and then there aren't any y's left. And so this is now factored. So you see what I mean by turning, addition, a sum of products, into a product of sums in this case, right? Turning that into multiplication, right? So that is what we're doing. So if we were going to, you could, we've seen this before, you could distribute this and then you'd end up back with this. So that's what we're doing here. So let's do this one. So is there any numbers in common over here? Well, yes. 2 goes into all of them. We're going to pull out a 2. We could pull out a -2 and flip all the signs, which log that away for an example in a minute. Are there any letters? Well, they all have an A. So they all have an A. And they also all have a b, so we're going to pull out a b as well. And then we're going to open parentheses and write down what's left. So don't forget to make sure the signs light up. -4 divided by 2 is -2. If we pull out an a and a b, then all that's left is an a, right? That's all that's left in this one. All that's left in this next one is -4 and a b, right? Not a b, but just b, right? Because this a got pulled out and one of those b's got pulled out. So all that's left is a b. And now this last one there's nothing, right? But it's not nothing, right? There is something. 2 divided by 2 isn't 0. A divided by a isn't 0. It's a 1, right? So on this last one, there's just a 1 left. There we go. Easy peasy lemon squeezy. Let's do the next thing. So now we're going to use that to factor by grouping. Now, when you continue to get more and more advanced and practice this kind of stuff more and more, maybe even in like Algebra 2 and those kind of things, it'll just say factor, or more likely it'll say solve for whatever, and you're going to have to factor it by grouping. Now, whenever we see an even number of terms and it says factor, that might be a clue that we're going to factor by grouping, because we need an even number of terms to factor by grouping. And the first thing you do to factor by grouping is you group it into 2 parts. So in this one, we're going to split it right down the middle. And often that's true. In Algebra 1, we pretty much always just split it in 2. In Algebra 2 and stuff, we may have to rearrange, and maybe even in some of the more advanced, some of the more scary homework problems, maybe, I don't know, I'd have to go look through all the homework problems in my class to see whether this is true or false. But in Algebra 2 and stuff, sometimes you have to rearrange things. And so I'm just kind of for future knowledge, you're wanting to look and see that the signs are either the same or opposite. Now, that's going to come into play here in a second, right? So once you've split it into 2, you're going to pull a GCF out of the front ones and then a GCF out of the back ones. So if I'm just looking at these 2 right here, what is the GCF between those 2? Well, it's a 4, and they both have an R. Right? And then we're going to write down what's left. So what's left is a 1Q, or just a Q, right? We don't usually write that 1 if there's a letter there, right? We're going to call that a Q. Why not? Plus 2, because we took that R out, right? That's what's left over here. Now, what's in common between these 2? Well, a 3 is in common. So we're going to pull out a plus 3. Okay? And we pull out a plus 3, what's left? We pulled out that 3, so a Q is left. And this last one, 6 divided by 3 is 2, so plus 2. Now, you should notice something, and I did this color changing on purpose, right? You notice perhaps that these both match. There's a 6 plus 2 and a 6 plus 2. You also, now this is harder to notice, that we've turned this thing that's got 4 terms into something that's got 2 terms, right? This is a term because it's all multiplied together and it's added to a second term, right? So we're going to GCF again. What's in common between this term and this term? Well, these 2 green bits are in common, right? So we're going to pull out the green bit, right? So we're going to pull out a, excuse me, Q plus 2. What is left when we pull, and then we're going to open parentheses and write down what's left. What's left in this first one is 4R. What's left in this next one is plus 3. Right? Easy peasy, lemon squeezy. Now it's completely factored. Right? Now let's look at this guy. This guy throws a wrench in the works. It shifts some things a little bit, right? So because the signs don't actually match. Now I'm going to walk this through in maybe one or two more steps than is strictly necessary. But let's start out by splitting this into two, just like we did a second ago, right? So let's look at a GCF in this first one. So there's a 2 in common in this first group, right? So we're going to pull out a 2. There's also an M in common. So we're going to pull out an M. Now when we pull out a 2M, what's left in the first one? Just a K. And what's left in the second one is a 6, because 12 divided by 2 is 6, and that M is pulled out, right? So in the second one, what are we going to pull out? We're going to pull out what's in common. Well, there's a 7 in common, right? So we're going to pull out a +7. And there's no letters in common, right? So what is left? Well, in this first one, there is a negative, right? Watch out for those signs. Or is that, no, that's not, it's not a negative. That's a positive. +6, right? Because it is plus. Rewind the tape, and I struck through it with a doomy flotchy. Excuse me. A 6 is left, and then a -K, because we pulled out that 7, right? Now, unlike this example, the orange parts over here, they don't match yet. They're in reverse order, which that we don't really care about. It may be harder to see, but that's fine because addition is commutative, right? We can reverse the order. But what we do care about is the signs. The signs are backwards. So what we're going to do to fix that is, instead of pulling out a +7, we're going to pull out a -7. So we're going to stay a 2M over here and write this as K -6. And then we're going to pull out a -7, which is going to flip the signs on both of these inside. So it's going to change this +1 to a -1. So a -6, and this -1 to a +1. So now they match. We're going to go ahead, just to make it extra clear, we're going to use the commutative property to change the order over here and turn this into 2M. Ooh, that was a weird looking M. Something happened. 2M times K -6 -7 times K -6. So now we have a K -6 in common between the two. So we're going to pull out a K -6, K -6, and we're going to write down what's left. What's left in this first one is 2M. What's left in this second one is -7. That was easy peasy, lemon squeezy. We got one more little thing and one more little example, and then we are going to be through. So the zero product property says for any real numbers A and B, if A times B equals 0, then A equals B, or A equals 0 or B equals 0, or both A and B equals 0. Now, what that lets us do, what this property effectively allows us to do, is solve a problem like these. It lets us solve something like this. Now, you might be tempted on this first one to say, oh, I've got to distribute. But that's going to go backwards. So because of the zero product property, what we can do here is, now that we have this left side completely factored, it's all factored. There's no addition or subtraction outside of parentheses. It's completely factored. Once we have it completely factored and equal to 0, then the next thing we can do is we can split this into two separate little baby equations, because we can set this one equal to 0 and this one equal to 0. So we can turn this into 2D plus 6 equals 0, and 3D minus 15 equals 0. Right, and then we can solve each one of those little baby equations, right? So for this one, we would subtract 6 from both sides. This one, we would add 15 to both sides. You don't have to do them both at the same time. You can do this one all the way, and then that one, because I changed colors on the intermediate steps, which I encourage you to do as well, it is easier to do intermediate steps as we go. So 0 minus 6 is -6. And then 3D we're bringing down equals 5. Over here, we're going to divide both sides by 2. And over here, we're going to divide by 3. That's an ugly 3, but you know, it'll be fine. And so we end up with D is equal to -3 from this one, and 5. I knew there was some mistake. I didn't think you're supposed to end it. That should have been a 15, right? That was a mistake. I wrote 15 here, but not 15 there. So not 5/3. Not 5/3 at all. How about +5? Sure, we'll let the color stand. There we go. So we had 2 solutions to this equation. We're actually going to have 2 solutions to this one as well. Now, this one, you may be thinking, you may be really tempted to be like, let's just divide by a C. Let's get rid of that. And then we end up with C equals 3. And that is a solution to this problem. The issue with that is this problem actually has 2 solutions. And we know that it has 2 solutions. Now, I say this is with a little bit of side knowledge that it does have 2 solutions. They might be the same number. That happens sometimes. But it has 2 solutions, and I know it has 2 solutions because it is a second-degree polynomial. Because it's a second-degree polynomial, I know that I expect 2 separate solutions. So what do we need to do with this? Well, we need to get it into a place where it's completely factored and equal to 0. So the equal to 0 is pretty easy to think through, right? We're just going to subtract 3c from both sides. We like that squared term to be positive in these, FYI, just as an aside, useful piece of information. So now we got c squared minus 3c equals 0. So I said real close to the beginning of this video that anytime you're doing a problem where you want to factor, you want to look for GCF first. And this one, that's exactly what you do, and that's pretty much all you do to factor this one is both of these terms have a c in them. So we're going to pull a c out. And then what's left? When we pull a c out of this first one, we're left with a c because it's got c squared. And then the second one's just minus 3. Now we have something that is completely factored and equal to 0, so we just split it into 2 baby equations. The first one is very simple. It's just c equals 0, right? Now, the second one, you may already, if you remember from the beginning of this, or before I started actually solving this problem correctly, you may have already realized a long time ago that this one is going to end up being c equals 3. To solve this, of course, we just add 3 to both sides. I keep doing ugly 3s in there. It'll be fine. We'll all live. C equals 3. And that, my friends, is the last example of this lesson. I'll see you in the next one. Thanks for playing along. Adios. Hasta luego. Have a great one.